Hey everybody, this video lesson is going to begin by covering the concept of the mole. The mole, what is it? Well, it could be representing a little growth on your skin. It could be a little fuzzy creature that burrows under the ground. But in fact, in chemistry, the mole, which is a word that is short for molecule, but doesn't actually mean molecule, is a unit of quantity. Think of some other units of quantity that you may have experienced in your everyday life. For example, a pair of something represents 2 objects, or even a dozen represents 12 objects. Another one is called a gross. Well, it's a dozen or 144 objects. But none of these really represent the amount of quantity of objects that a mole is equal to. A mole is equal to 6.02 times 10 to the 23rd objects. You heard that right, 10 to the 23rd. 602 with 21 zeros after it. Now, practically speaking, this number is astronomically large. It really is very difficult to wrap your mind around how many objects that really is. But when you're talking about things that are as small as atoms and molecules, a mole equals about the amount that can fit in the palm of your hand. So as chemists, we made up this unit to represent an incredibly small object, a molecule or atom. And instead of thinking about them in just individuals, rather we talk about them in whole groups of molecules and atoms known as moles. Now you can count other things in moles like cars. You can have a mole of cars or a mole of human beings or a mole of grains of sand, but they're not practical. You wouldn't count these objects using the mole. Now what is the importance of this number, 6.02 times 10 to the 23rd? Well, it is known as Avogadro's number, or sometimes referred to as Avogadro's constant. Now, Amedeo Avogadro is an Italian scientist who came up with the concept of the mole. Now, I will admit that it is kind of an awkward number to use. It is not something that comes to you intuitively, but it is something that you'll be expected to know what it is and how to use it to convert between moles and quantity of objects, specifically atoms and molecules. Now, one thing that's nice about Avogadro's number, or Avogadro's constant, is that it is indeed constant. So the number is the same no matter what you have. No matter if you have atoms or molecules, the number remains 6.02 times 10 to the 23rd. And another use for Avogadro's number is that it can be used as a conversion in dimensional analysis. So let me scroll up here and give myself a little bit more room. Here's a problem that I might pose to you. How many moles are in 5.0 times 10 to the 20th molecules of copper? Well, this is a pretty straightforward dimensional analysis question. You have a starting number, and you're going to convert from molecules to moles, and you're going to use Avogadro's number up here as a conversion factor. So like any dimensional analysis problem, you begin the problem with the number given in the original problem. In this case, 5.0 times 10 to the 20th molecules. Now I multiply by a conversion factor, and I'm going to match molecules in the top left with molecules in the bottom right. And I'm going to drop moles in the top of this conversion because it's what I'm going to be converting to. Now all I need to do is take the numbers from Avogadro's constant and plug it in. 1 mole is equal to 6.02 times 10 to the 23rd molecules. Now I just plug this into my calculator and I hit equals. Your calculator probably comes out with this number, 8.3056 e to the negative 4. And what that really means is that you've got 8.3 times 10 to the negative 4th, because in your calculator, the capital E stands in for times 10, and the negative 4 is the exponent of that times 10. And so I rounded this off to 2 digits, meaning 2 significant figures, and I wrote it in the correct way. You may not write E negative 4 on any quiz or test because that's not acceptable use of a scientific notation. You have to write times 10 to the negative 4. This is something your calculator shows you, but this is what you actually want to write in. Of course, you want to label this moles. Now, of course, if you can go from molecules to moles, you can also go from moles to molecules. For example, this problem. How many molecules of NaCl are in 3.5 moles? Now, just like my other problem, I want to begin by writing out the number given to me in the problem, including its units, over 1. I'm going to multiply by a fraction, and I'm going to match moles top left and bottom right because I need those to cancel out. I'm going to write molecules in the top right, and now I'm going to plug in the numbers from Avogadro's constant. This time, instead of dividing by Avogadro's constant like I did it up in the one above, I'm actually going to put the 1 mole on the bottom and the 6.02 times 10 to the 23rd on top. A word of note, I didn't mention this in the last practice problem, but it's probably a good idea to put this number in parentheses whenever you're putting it into your calculator so that you don't accidentally multiply part of Avogadro's constant by something. If you put it in parentheses, you'll be pretty safe when doing the calculation. So you multiply these two together and you get 2.1 E24. What that really means, that's calculator language. What you really want to write is 2.1 times 10 to the 24th molecules in order to get the correct answer. So in summary, mole is a unit of quantity. It's equal to 6.02 times 10 to the 23rd particles. It is known as Avogadro's constant. And finally, can be used to calculate between moles and molecules using dimensional analysis. And these are the 4 most important things that you need to know about the mole after this first video lesson. Well, that takes care of this one. Thanks for listening.